Hello everyone, am I audible? Okay, fine. So I think I'm audible to everyone. So guys, I think last time we were talking about visualization, and we have discussed about basically pandas, PLOT, PLOT. Okay. So I think in last class we were talking about basically like how we can try to do a visualization in pandas plot basically or matplotlib. So in today's class we are going to extend same lecture, and we are going to talk about like how we can try to utilize some other library which is better than like a matplotlib, and then how we'll be able to perform the visualization. So fine guys, let's try to start. Let's try to start with this visualization chapter. So okay. Fine. So the next library that we are going to talk about is a Plotly. And Plotly is basically like a much more powerful, I would say, or much more interactive library as compared to Pandas, I would say. So like as compared to Pandas, Plotly is actually beautiful libraries, and it gives you a lot of functionalities, or it gives you a lot of flexibility to perform many different kind of operation. Now, as far as this graph is concerned, so different graph plot is concerned. So again, you won't find much differences. So whatever you can do inside a matplotlib or inside a pandas plot, similar kind of a thing you will be able to perform even with the help of plotly without any if and but. By default, plotly will not be available inside your system. That is true, yes. So what you will have to do is, so you will have to perform a installation. So again, you can try to install this particular plotly libraries from anaconda prompt. That is possible. Or else what you can do is you can try to perform this plotly installation from your Anaconda Navigator, Anaconda prompt, or maybe from your Jupyter notebook. So anyway, you will be able to install this plotly library, and then you will be able to utilize it. So here, as you can see, so I'm trying to perform like a pip install plotly, and again pip install cufflinks and pip install folium. So folium is another library you will be able to find out. So here, whenever you will try to install something which is not available inside your anaconda environment, so we generally use pip. Pip is nothing but it's a repository, and I think you might be aware about that. And going forward, you are going to install many different kind of custom libraries, because going forward, whenever we'll try to do a project, so these library will not be available inside your system. So anyhow, you will have to perform a custom installation, and then only you will be able to like understand, or you will be able to utilize these kind of libraries. So fine guys, so here I'm just trying to perform an installation. So if I'm going to execute these things, so it is going to give me like a requirement already satisfied. So I will not be able to get it is not going to install something for me, something new for me, because it's already installed basically. But at the same point of a time, so at the same point of a time, so you will be able to find out in your system that yes, it is going to install. Sometime you are going to get some deprecation warning, or maybe some kind of like a warnings it is going to give you. It's completely fine, you can just ignore that one. That's not, no need to worry about all those things. So fine, all those libraries are available inside my system. What I will do is I will just try to do a import. So if I'm going to import, so I'm going to import my pandas numpy cborn library, which we are going to discuss after this library for sure, and a matplotlib. And I'm trying to import like a plotly offline, plotly tool. So these are just a generic import. Now, so we have actually installed three libraries. So here the second library is a cufflinks. So cufflinks is basically a configuration library for a plotly. So at any point of a time, if you have to do some kind of a configurational changes, so in that case, for sure, you are supposed to use this cufflinks library. And with the help of that, so you will be able to change a background, or maybe a setting, or many things, many like a configuration operations are possible with the help of this. So fine, this is what I will be talking about. So I'm just going to import this library, as you can see, and then these are the kind of a graph which we'll be talking about, like how we can try to plot a line graph, or maybe a scatter plot, or maybe a bar graph, or maybe like a box plot, or maybe how we can plot like a spread graph, or maybe a ratio heat map. So many more things we will be talking about in this particular contest. So fine, let's try to understand it, and let's try to find out that how this graph is going to work actually. So here I'm just trying to check my like version of this plotly, and it's completely fine. So this is the version, and then I'm going for offline because I have to plot each and everything into a offline mode. Again, I will show you that plotly provides you online dashboard as well. So if you want, you can try to plot these things into a offline mode, or if you want, so you can try to plot these things into a plotly dashboard itself. So many more features are available in case of a plotly. And again, so you can try to call like all of those libraries through a API as well. That is also fine, and it is going to work for you. So here I'm trying to like perform py.offline init notebook mode, and so that I will be able to perform every operation inside my local notebook. Many of you are going to face a problem because of this particular things. If you are not going to import this particular things in your notebook, you will be able to find out that it is not going to give you a graph. It is not going to give you a final graph. So make sure that you are going to import these particular things so that you are not going to face any kind of a issue or any kind of a problem. Now, so here I'm just going offline with respect to this particular plotly, and then on top of that, so I'm trying to create a data frame, a very simple data frame I'm trying to create in this particular place. Now what I will try to do after creation of this data frame, so basically I will try to plot it. So I'm just trying to create a simple data frame over here with a 3 columns. So I have used basically a numpy.random.randin so that I will be able to generate a random data, and then I can go through like a different kind of a data plotting operation. Now here, so you will be able to find out that this is my data set. I have my A column, I have my B column, I have my C column, and I have indexes. Now what is next which I'm going to do? So I'm looking for a line plot. I wanted to understand that how my data set is varying inside a column A, inside a column B, and inside a column C. This is what I'm interested in doing, and this is what I wanted to understand. This is what I wanted to know, that okay, so in column A, so how my data set fluctuates, in column B how my data set is going to vary, and all those things. A very simple operation, the same kind of operations that we have already discussed or that we have already seen in case of a pandas. So pandas plot basically, or matplotlib I would say. So if I'm interested into this kind of operation, so simple, it's so just it's the same as I would say a matplotlib or pandas plot that you have done. So I have taken this particular data frame, and then on top of that, so I'm trying to call data frame dot iplot. So if I'm going to perform data frame dot iplot, basically over here in this particular place, data frame dot iplot, if I'm going to do, so it is going to give me this kind of a graph. Now this kind of a graph is a bit different. So here I have added just one word, iplot, I. So plot was even available in case of a pandas plot. It was the same method, it was the same function that we have been using, but here you will be able to find out only one differences, which is a I. So you will not find many differences in terms of a method or in terms of functionality. Plotly has made your life very easy. So Plotly has made your life very easy in such a way that without writing much line of a code, you will be able to plot an interactive graph. Now, if I'll try to hover my mouse over here, so this graph is much more interactive. Whenever I will try to hover my mouse, so it will always try to show me basically like a x-axis value and a y-axis value. Yes, for sure, x-axis value is nothing but it's a indexes, and then y-axis value is nothing but the data set which is available inside my column, and with the help of that it is trying to create a pair. So a pair for each and every dot. So here you will be able to find out that beautifully it is able to show me. So beautifully it is able to show me like each and every kind of a like it is able to show me each and every coordinates or each and every like a pairs it is able to show me. So there won't be any concern, there won't be any issue at all. And then on top of that, so what I can do, so if I wanted to download this picture as a JPG, so these options are available over here itself. So if I wanted to like include these things into maybe my PPT or somewhere else, so yes, I can do that. As you can see, it is completely possible to perform this kind of operations just from here itself. If I wanted to perform a zoom in or zoom out, so if I wanted to observe or if I wanted to study some section of this graph, so I will be able to observe or I will be able to study a section of the graph easily. So as you can see, so till what extent I will be able to zoom in. So I will be able to perform a zoom in operations in this particular case very easily. So it's again gives us a beautiful feature. So from here itself, so if I wanted to like perform zoom in, zoom out in this particular way, yes, it is possible. Or what you can do is, so if you wanted to reset the axis, so you can do that as well. So you can try to perform the reset axis, and if you wanted to perform basically these things, these operations with respect to a plotly, you can do that as well. Or is there is an option which is available over here, export to plotly. So if I'm going to click in this particular place, now let's see what happens and what kind of a outcome we are going to get. So like I told you, so like I told you, it's a very interactive graph. So it's very interactive graph, and you will be able to perform many kind of operations. And yes, it will it will, you will be able to perform many different kind of operation even into a real time. For example, so here I was trying to plot this graph inside my local system, as you can see. And on top of that, so what we are trying to do is, so we were trying to perform this operation into a local system, and then on top of that, so we are we wanted to perform some kind of a real-time analysis. We wanted to see that if we are going to change this value or that value, how my graph will behave. So in that case, you can try to click on export to plotly, and then it will try to open up your same graph with the same data set into a plotly online format. So here it's not my notebook now, it's basically a plotly dashboard itself. You will be able to see that. So it is going to launch your graph into a plotly, and this is like a same data set that you have been using. So it will try to import all of your data set in a first place. Now let's suppose if I wanted to change this value, so let's suppose if I'm going to change this value to 23, and now if I wanted to see that, okay, so how my data set is going to behave. Suppose if I have made a changes 890 over here, and then if I'm going to hit enter, you will be able to find out all those changes into a real time without writing a code or without doing any kind of execution or without updating. So it's updation of the data is very much possible or very much easy in terms of here. So in terms of here, and based on that, you will be able to see your graph. You can try to import some other data set as well, and then on top of that, you will be able to perform a similar kind of a like a operation, similar kind of a graph operations in a very easiest possible way. So this is how a plotly is going to help you out at any point of a time. So this is how like a plotly is going to give you a interactiveness. Now let's suppose then and there, so what I want is, so for a column C, this is the column C. So for a column C, if I'm looking for a scatter plot, so if I'm going to perform like a scatter plot for the column C, how it will look like. Or maybe for a column B, so I wanted to draw maybe a bar chart. So I wanted to know that how it will look like if I'm going to plot into a bar chart. Or maybe for a column A, so I wanted to perform maybe like something like, I would say line area, so area plot. So suppose if I wanted to do an area plot for column A, so you will be able to find out that it has performed a different kind of operations for same data set, and you are able to get a different kind of a graph for sure. Again, if you wanted to flip this graph horizontally, vertically, you will be able to do that. Each and everything is possible in this particular place, and in the easiest possible manner. In the easiest possible manner, it is possible. You can try to import your data set inside a plotly dashboard, and then you will be able to perform this interactive use cases, or you will be able to perform this interactive things. Interactive, I would say, like graphical changes you will be able to do, and then you can try to import it, you can utilize it anywhere. So this is a facilities which has been given by a plotly, which is not available in case of a matplotlib. So don't even think about using a matplotlib if you are looking for this kind of a flexibility. Now apart from that, so there is like a x-axis, y-axis. You can try to alter like a x-axis and y-axis, and also you will be able to find many other changes. If you wanted to, there are many more functionality as well which is available. So suppose if I wanted to plot maybe a multiple graphs over here, I can try to do that, and then I can try to import those things as an images. That is also possible in this particular case. So beautification wise, it gives you every kind of flexibility. It always gives you every kind of flexibility, so that you will be able to get each and everything. So anchor also you will be able to change. As you can see, I have just shifted my coordinates value, x value and y value from here to here. So it's very easy, it's very much possible, I would say. So in this particular case, and apart from that, so you will be able to perform any kind of a transformations as well. If you wanted to perform like a filter operations, or maybe if you wanted to perform some kind of a transformation operation, some kind of a data transformation, maybe like a categorical to a numerical, or maybe a date range function, maybe some kind of a aggregation operation, or maybe some kind of a sorting operation if you wanted to perform. So even those operations are possible with respect to Plotly and without writing a code. That is also possible in this particular case. So with respect to each and every column, so these are the operations as of now they have given, like a filter or split operation, or maybe aggregate operation, or maybe a sort operation. So inside the aggregation operation, so many more operations are available. Now theme wise, so you will be able to choose any kind of a theme over here. Theme is nothing but a background and appearance, so nothing more. So you will be able to beautify it. They have given you a multiple themes in this particular place, so based on your need, based on your choice, so you can go ahead with any other kind of a theme. Now so you can create your own theme as well, and you will be able to save your entire work into a Plotly once you will be able to log in inside the Plotly. As of now I have not logged in, so without logging into a Plotly itself, I'm able to see each and everything. So if you wanted to save your work, if you are working on some graph or some data set, and you will be able to do that. Now so Plotly provides you enterprise version as well. So if you are using an enterprise version, so in that case you will end up getting like a connectors, a different kind of a connectors for the data analysis. So this is how Plotly has been designed. Now style wise, if you are looking for some kind of a color combination, some color changes, any kind of a styling that you can think of in terms of a font, in terms of maybe like a layout, colors, lines, everything, so everything is possible. You will be able to perform all sort of operations from here. Now if you are working on an axis, and if you wanted to change your axis, x-axis to y-axis, y-axis to x-axis, if you wanted to like do some kind of a modification, everything is possible in this particular case. So you will be able to maintain, manage each and everything, access legends, everything over here. So legend wise, so yes, you will be able to find out this legend, you will be able to see these legends automatically. So as you can see, so here is a legend, this is a legend. And if I'm going to click on horizontal, so here you will be able to find out a legend, same ABC, this is called as a legend. If I'm going to click on vertical, so I will be able to find over here. So this option is also possible. Now you will be able to annotate your own data set if you want. So you can write maybe a text, or maybe import a data, and then you can try to plot it. Save wise, so yes, you will be able to perform a different kind of operations. So line, graph, shape, or maybe eclipse. If you wanted to draw many things like I told you is possible in this particular case. So analyze a data. So if you are looking for some kind of an analysis, maybe a moving average analysis, or maybe like this data is fit for my linear regression or not, so or quadratic equation or not, you will be able to perform this kind of operations with respect to any other values. So this is going to give you basically a data analysis, basically like I'm looking for a linear fit, so it is going to give me a linear equation over here. Or suppose if I'm looking for maybe a second order, third order, so accordingly it will try to change my equation, and whatever value which I'm going to give, so it will try to pick and choose those values. So again, for they're just trying to develop it actually. So this things was not available a couple of months back, but as of now they're just trying to develop it. So maybe in a future, so you will end up getting many other feature as well. So moving average, generally we try to take care of a moving average in terms of, I would say, like time series. So ACF, PSCF values we try to calculate, and even here, so you will be able to find out those things, and you will be able to find out, or like you will be able to do a moving average thing. So in time series you will get this term again. If you wanted to save your data, yes, you can save it. If you wanted to save these things as an HTML, so yes, you will be able to save these things as an HTML. So it will be like a graph itself, it will be a graph itself. In that case, like you will be able to get some kind of an interactiveness, you will be able to get some kind of an interactive graph in that particular case. So fine. Now if I wanted to import a data as a JSON, so I will be able to import my data. So as not only I will be able to import a data, whatever changes which I have done in terms of a layout, in terms of margin, in terms of a colors, in terms of like some kind of matrices, so I will be able to get every data set inside this JSON. If I can read this data set, I will be able to get many more information, and based on that, maybe I will be able to replicate it. So it generates this JSON code as well. So yes, your data set is not going anywhere, your data set is completely intact, as you can see. So whatever data set that you have given as a data, as a B data, or as a C column data, everything is there. But the thing is, like, apart from that, so it is going to give you other features as well. So it is going to store other things as well, and at any point of a time you can try to export these data, and then you will be able to work on these data set. So this is how this things is going to actually works, and it gives you many more functionalities. Now in its enterprise version, so this is something which is available just for free. So if you are looking for an enterprise version, so in enterprise version you will be able to like get many more other features as well. So this is how you will be able to find out that many more other features are available in an enterprise version, and very easily you will be able to like perform these kind of operations without any hassle, without like any other things. So just try to like explore these things, just try to maybe look into this particular one, and you will be able to get many more insights without writing a code. Apart from that, so in yesterday's class itself I was talking about this one thing. So there is a like a library called as DASH, so dash basically. So there is another library which is called as a dash, which you will be able to find out, which has been built based on plotly itself. So which has been built plot based on completely based on the plotly, and it gives you many more other functionality, like if I have to host my graph, or maybe if I have to integrate these things with the HTML, even with the help of plotly you will be able to do it. But the thing is, with a dash, so they have given you many other feature for a real-time integration basically. So real-time dashboarding, real-time integration, real-time data analysis. So for that they have given you many more features, and inside a dash, so you will be able to use the same plotly library. So whatever you are going to learn, so you will be able to use a same thing, and then you can perform many other operations. This is what happens in case of a dash. Now you might have heard about COVID-19 dashboard. So in government dashboard, so COVID-19. Now if you will go to this COVID-19 in a government dashboard, not this one. Yeah, if you will just look into this dashboard, so this dashboard is completely built on a dash and plotly. So this is like a beautiful, this is the beautiful dashboard which people have built based on the same library. So this dashboard is completely built into a Python. You can go through this GitHub. So they have open sourced this GitHub code as well. So you can just look into the GitHub code, you will be able to find out. Recently, just last week itself, so they have open sourced this GitHub code, so that you can look into a GitHub code as well. And if you wanted to replicate in an easiest possible manner, you will be able to replicate all of those things inside your system. Or maybe if you are looking for some kind of a modification, so you can try to do those things as well, because entire code is available. It's been released by a government itself. So this entire dashboard, like I told you, so entire dashboard is built on top of a dash basically. And dash is a kind of a supporting library which will always helps you out to like which always helps you out to understand, like to maybe plot this kind of a data or the graph for the interactive purposes, and so that you will be able to like refresh it, you will be able to perform these operations into a real time. So yeah, it's very interactive. It's very easy to like perform this kind of operations if I'm able to get this kind of libraries. So this is like one of the beautiful application which people have developed recently, which you will be able to find out, like the way this presentation has been done is beautiful, and they are doing these things with the help of dash libraries. And yes, it's very much interactive, I would say. So this is a real-time example. You can try to create your own graph in a similar way with the help of plotly and a dash library. Maybe you will have to explore in that case. So getting back to my discussion, so this is the flexibility, this is the functionalities which you will be able to get inside a plotly, which you won't be able to get in any other libraries. Now, so similar plot I'm trying to do, so similar kind of a plot I'm going to do inside a pandas plot, or maybe matplotlib we can say. So here, if I'm going to plot a same data, this is how my data set looks like. So graph wise, it's completely fine. Sentiment wise, it's completely fine. It is going to give you a similar kind of a graph, exactly same graph it is going to give you. But the thing is, like, you will not be able to get some kind of interactiveness. You will not be able to get a beautification by default. You will have to write a lots of line of a code. You will have to write a parameter, many other parameter you will have to adjust, and even after that, maybe you will not be able to get this kind of a graph. Interactiveness wise or dynamic graph wise, not at all. So Matplotlib doesn't support even those things. But here, if I'll talk about a Plotly, so yes, Plotly supports all those things, and you will be able to get it very easily in case of a Plotly. This is what I'm trying to do in this particular case. So here is my data frame. So what I'm trying to do is, so I'm trying to perform this this scatter plot kind of a operation. So let me reduce a size. I think that'll be better. Okay, so if I wanted to perform maybe a scatter plot kind of operations, if I wanted to plot these graphs, so what I can do is I can try to call a data frame dot iplot, and then I can try to write x is equal to a column, y is equal to b column. So simple. In a scatter plot, we all know that I need just only one thing. So I need basically my x-axis value. So to plot or to print any of the points, I just need maybe my x-axis value and y-axis value. So I'm trying to make my x-axis and y-axis, and based on that, so I'm trying to plot it. So x-axis is equal to a column and b column. Here I'm just trying to opt for the marker mode, which is nothing but a scatter plot, and size is nothing but size of all those bubbles which it is trying to create. So you can try to increase, you can try to decrease, depends upon your like a look and feel that you are looking for. So this is something that we are like able to perform. And now the next thing that we are going to perform is, so I'm going to load a Titan data set, as you can see. So I think we have discussed about this data. So this is the open source data. I'm just trying to load it so that I will be able to show you a different kind of a operation. So fine, I'm trying to load this Titan data set. So sns.load data set, and then I'm trying to pass this Titanic. So after passing this Titanic value, so it's completely fine. This is the same old data set. And then what I'm trying to do is, so data frame, so Titanic data frame dot iplot, and kind is equal to, I have given is equal to bar. So kind is equal to bar, which I have given, nothing much. And x-axis is equal to 6 column, y-axis is equal to survived column. So I'm actually looking for a bar plot. So as we all know that if we are looking for a bar plot, so for sure there will be an x-axis and there will be an y-axis, and then there will be an bar. So bar always depends upon, I would say, like x-axis and then respective y-axis value. So let's suppose if I have given 6 column over here, so inside a 6 column we have a male and we have a female. So whatever number of the data that we have for the male, so it is going to represent that as an height of the bar. And then whatever data we have inside a female, so that has been represented as a height of the female bar. As simple as that. And then a title is nothing but, so title of the graph which I wanted to give. So as you can see, we have a survived as a title, and x-axis title I have given over here, and y-axis title I have given over here. So you can try to give any other kind of a title that you want, or you can try to give any names that you are looking for. There won't be any kind of a concern, there won't be any kind of a issue. So this is something that I'm trying to perform. So I'm trying to perform a categorical versus a numerical representation, you can just try to say. So I'm just trying to plot a bar plot over here, and with the help of bar plot, yes, you will be able to perform all sort of operations. That is completely fine. Now the next graph which I will be talking about is, so here what we can do is, so if we are going to call a value underscore count, so if we are going to call value underscore count, so what happens when we are going to call value underscore count? So whenever we are going to call value underscore count, so it will always try to perform a grouping operation, and for every group, so it is going to give me a data. This is the same thing you will be able to observe in case of a bar plot. So you will be able to find out that it is trying to perform a grouping operations. It is trying to group my data set on a x-axis and as well as on a y-axis, and based on that, so I'm able to get my result, I'm able to get my answer. Now here you will be able to find out that there is something called as a configuration cf.getTheme. So this is a configurable parameter. You will be able to find out. Suppose here, if I'm going to click over here, and it will try to give me like what are all themes which is available. So theme means background. So I think you might have seen a theme even over here. So in even inside the graph, so you might have seen a theme, terrace support line, and theme. So theme is available here. So you can try to choose any kind of a theme, and based on that, so it will try to change a background. So similar kind of a theme you will be able to perform, or you will be able to select based on your this particular theme options. So it will try to change a background and some kind of a formatting it will try to give you. So as of now I'm trying to use a polar, so solar basically. So maybe I can try to opt for the polar, and you will be able to find out differences over here very clearly. So as you can see, so now my background is not black. So till last graph, so it was basically a black, but now my background has changed, my presentation has changed basically. And this is what theme does. Now again, if I'm going to make it as a solar, so in that case my background will change. Simple. So this is just a theme. This is just going to change your colors, nothing much, nothing else. It's a very simple operations which we are trying to perform. Now here, so I'm trying to set this particular configuration, so which will be available throughout the session. So config, so cf dot set config file. So cufflinks and theme I'm trying to set over here in this particular place. And then I'm trying to call like a data frame dot iplot. So simple, I'm trying to perform a bar plot. The only difference is like I'm trying to give a bar mode is equal to a stack. So it will try to plot a bar, and one on top of other a bar it is going to keep. That's the only thing which it is going to perform. So it will try to create one bar, and then on top of this bar, so it will try to create another bar. That's it. That's the only thing which it will try to give. Then a bar mode is equal to 0.1 it is going to give you. So 0.1, 0.3, whatever you want. So it is just trying to control your bar width. That's it, nothing much. Now, so here, same thing, here, same thing, you will be able to find out. The only difference is I'm trying to flip my bar. So I'm trying to use my bar edge, bar horizontal, nothing much, nothing else over here. Now, what is the next thing which I'm trying to perform? So here I'm trying to perform a box plot. Box plot is a special kind of a graph that you will be able to find out. So let's try to understand that what is box plot and what in all like a result it is going to give you. So box plot is actually like yeah, it's a very good graph, and it try to give you like many insights. It's always try to give you like if you have some kind of outliers, it will try to tell you that okay, so there is a outliers which is available. So it will try to tell you that, okay, fine, so this is the outliers which is available. And after observing your outliers, so you can try to treat or you can try to handle those outliers. So as far as this box plot is concerned, so you will be able to like you will be able to basically build this one. So suppose if I'm going to talk about this bar plot or this bar plot, so this is the bar plot for a column A, this is for column B, and this is for column C. So here you will be able to find out that this is going to give you a minimum. This is called as a quartile 1, this is called as a quartile 3, and this is called as a maximum. Now, so as far as this quartile 1, quartile 3 maximum and minimum is concerned, so quartile 1 is nothing but, so you might have seen inside a pandas in a summary tab. So it always gives you 25th percentile, 75 percentile, 50th percentile, or it try to give you like minimum and maximum. So it's the same kind of observation you will be able to get over here, but little bit in a different way. So here you will be able to find out that it is going to give you a quartile 1, quartile 3, a maximum and a minimum. And this is called as a IQR, interquartile range, means a range between quartiles. So from where to where my data set is fluctuating. Now, if I'll talk about a quartile 3 or quartile 1, so quartile 1 is nothing but, so Q1 is nothing but it's a 25th percentile of data. 25th percentile. So if I have like 100 data, so you will try to arrange it into a ascending order, and then after that, so data which is available at 25th indexes will be called as a 25th percentile. So that will be a 25th of the data set, as simple as that. Now, so that is a data which has been represented by a Q1. So Q1 will always try to hold a 25th percentile of the data. Now, if I'll talk about this one, this is not nothing but a median. So I think we all know what is median. So just try to arrange the data and try to pick a middle value. That is called as a median. And again, I will try to cover this median, mean, and mode kind of a concept in your statistics class in very detail with a real-time implementation. That mean, median, and mode is a very small thing, but still how we can try to use these things to perform different kind of analysis. So this data set is nothing but a median, or you can say it's a 50th percentile of the data. So median is nothing but 50th percentile of the data. Now there is something called as a Q3. So Q3 is nothing but 75th percentile of data. So simple, Q1 is nothing but 25th percentile, mid is nothing but 50th percentile, and then Q3 is nothing but 75th percentile again. So don't try to confuse yourself with 75% and 50% and 25%. So it's a 70th basically. So when I talk about 70th, it simply means that, so I'm talking about basically indexes. I'm not talking about a 75 percentage of the entire data set. So I think we have discussed these things even inside the pandas class. If you have a confusion, please go and look into your pandas lecture. You will be able to get your answer. So that is completely fine. So we have like a Q1, we have a Q3 over here. So this is completely fine. Now, so what is minimum, what is maximum? So minimum and maximum is nothing but, so if I'll talk about a maximum, so maximum is nothing but a Q3 data set plus 1.5 times IQR. That is called as a maximum. Now, why we are defining maximum with the help of formula? And here, so minimum is nothing but, so Q1 minus 1.5 times IQR, interquartile range. So what is a meaning of this? So like I told you, this box plot is being used basically to perform or to identify an outliers. So, and to just check like my data set is varying from where to where, in what set, or in what percentile, or in what quartiles. So my data set is more or my data set is less. So just to perform this kind of observation, so we are going to use a box plot. Now here, as you can see, so I have written minimum. So minimum is nothing but, so Q1. So whatever 25th percentile data that you will be able to find out. So minimum will be nothing but, so basically like 25th percentile data, which is nothing but, I'm trying to say Q1. So yes, Q1 is nothing but 25th percentile of the data minus 1.5 times then a difference between Q3 and Q1. So Q3 data, whatever data that you have, so Q3 difference between these two, so it is, you are going to take that as a minimum. It means that, so any data set below that data, so any data set below this calculation that you are going to do, so any data below this calculation is going to be an low outlier, and it is going to calculate a maximum basically. So Q3, so it's nothing but Q3 plus 1.5 times IQR. So any data beyond this maximum limit is considered as an outlier. As simple as that. That's the reason. So we are going to use this formula. So minimum and maximum, so any data below this minimum is going to be an outlier, low outlier. Any data above this maximum is going to be the outliers. So it's very simple. So you are just supposed to remember all of those words. So minimum, then maximum, Q1, Q2, Q3, or Q1, median, Q3. Simple. Q1 is nothing but 25th percentile, Q3 is nothing but 75th percentile, median is nothing but 50th percentile, and minimum is nothing but, so Q1, this one, minus 1.5 times then IQR, interquartile range. Interquartile range is nothing but a difference between Q3 and Q1. So whatever data that you have, so difference between these two is called as a interquartile range. Any data below this minimum is called as a low outlier. Any data above this range is called as a high outlier. This is how it is going to help you out to visualize like outliers basically. So again, in my Seaborn library, I have taken a data where we have a like outliers, and I will try to show you those examples over there. So it's completely fine, guys. So this is how it is going to behave, and you will be able to find out this kind of interactive things. So this is, I think, the same thing I was talking about: a minimum, Q1, median, Q3, and maximum. So median is nothing but a 50th percentile of the data set, and B1 is Q3, and basically maximum has been calculated based on this Q3. So maximum is nothing but so Q3 plus 1.5 times. Then so any data below this is completely fine, but above this is not fine. So it will try to plot, or it will try to show you this a dot 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 over here and dot 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 over here in this particular place, and you will be able to find out that yes, this data set is basically having an outlier. And based on that, so if I'm able to find out that I have outliers inside the column A, so I can try to perform some kind of operations by which I will be able to remove the outliers. So which I will be able to discuss in your ML classes as well as inside your statistics classes, because ML and statistics so will keep on doing this kind of operations on a continuous basis. So it's completely fine. This one is also fine, not an issue. Now, the next thing that we are going to talk about is, I think this is all about a box plot. The next thing which I'm going to talk about is an area plot. So area plot is nothing but, so it will try to show you some kind of an area. It always shows that if I'm going to change a theme. Now here, so I'm just trying to create a data frame, as you can see. And if I can try to so what I'm trying to do over here is, as you can see, I'm trying to call this a D3. So D3 is what? So D3 is basically my data frame. So I'm trying to call this D3, and I have basically like a X, Y, Z. I have 3 column, and I wanted to plot, or I wanted to see that, okay, so what is a shape of the data into a 3D axis if I wanted to perform this kind of operations. So yes, I will be able to perform those operations. So I can try to call a D3 plot kind is equal to surface. So surface is basically I would say it's a kind of a 3D graph. So surface is basically a 3D graph. So you will be able to find out that this is the 3D graph which I am able to plot over here. And I can try to hover mouse anywhere, and I will be able to get each and every coordinates, each and every data points which I have given in my data set. That is pretty much easy. Now, if I wanted to let's suppose, so if I wanted to plot, let's suppose I'm going to take a DF. Now, if I wanted to know that, okay, fine, so how my DF looks like in case of a surface. So this is the data which we have created, a random data. So I can try to take that as well. And yes, for that, so it is going to give me this kind of a graph. So this is going to show me that, okay, fine, so this is how this entire data set looks like, as simple as that. So you will be able to find out that yes, this is how my entire data set looks like, and along with the data, it is going to give you X coordinate, Y coordinate, as well as Z coordinate. So this is how you will be able to plot a graph into a 3D, and it's nothing but it's just going to show you like a shapes of the data. That's it. And it's very easy actually. So see, like I'm trying to call a data frame, and then a data frame, just try to create it, and it must be having 3 numerical values, 3 numerical columns. So column XYZ or ABC, whatever you want, and then you can try to perform this kind of a operation. You can try to give like a surface, you can try to give like a 3D graph, which I'm going to perform in the next step. So it's completely fine. You will be able to perform this kind of a operation. So here you will be able to find out that I'm trying to call CF configuration dot data gen. So I'm just wanted to know that what in all data it will be able to generate, and what in all parameters are there inside this configuration library. It's simple help function. So if you are going to type anything inside the help, you will be able to get some kind of help, but not for all the commands. So I was just trying to perform this 3D plot operation. So it's completely fine. Surface plot I was able to do. So this is the surface plot which I am able to perform, which I am able to do it. Now, so the next thing which I wanted to perform over here is I'm just going to take this data frame, and then I'm trying to call like a data frame dot plot, and kind is equal to a scatter 3D. So scatter 3D is nothing but, so it is going to give you like a dot 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 bubbles and all those things. So as you can see, if I'm going to hold my mouse over here, and let me try to print my DF as well. Let me try to print my DF as well. So this is my DF, and if I'm going to hold my mouse in this particular place, so what you will be able to find out. So what you will be able to find out in this particular place. So here, everywhere you will be able to find out X coordinate, Y coordinate, and Z coordinate. Along with that, you will be able to find out your indexes. So 85 is basically our index, and X, Y, Z is nothing but it's a coordinate values. That's it, nothing else. So I'm just trying to do a mapping over here. So I'm just trying to call my data frame, and then x-axis is equal to column A, then y-axis is equal to column B, z-axis is equal to column C. So you just need a data. That's it. You just need a data. You can try to perform the mapping operation, and then based on the mapping, so you will be able to plot it. You will be able to print it in a easiest possible manner, in a easiest possible way. This is how it is going to happen, I would say. Nothing else. Now apart from that, so like I can try to create maybe this kind of a graph, a spread graph, that is fine. Apart from that, so I can try to perform like a histogram. So I think we talked about a histogram, so even in last class. So histogram is nothing but a kind of a graph again, it's a very useful graph lots and lots of times. So histogram is nothing but it's a kind of a graph. So in a x-axis it will try to give you a range, and in a y-axis it will try to give you like uh, data set, number of the data which is available in between that range. This is what histogram does. So everywhere definition of histogram is not going to change at all. You will be able to find out the same thing. Here I have given some parameters specific to plotly. So bar mode is equal to overlays is nothing but, so it will try to overlap like multiple columns. If I'm just going to remove it, you will be able to find out that yeah, it's completely fine in this case. So again, bins is nothing but size of the or width of the entire like a bar which it is going to plot. So if you are going to increase or decrease accordingly, your bin size or your width of the graph is going to change. So it's just a part of verification. Bar gap is nothing but a gap between the bars. So again, that is just for the controlling your structure of the graph. That's it. So this is something that you will be able to find out. Same thing we have discussed, same thing we have done even inside the matplotlib. So this is fine, this is fine. Then heat map. So let's talk about a heat map. So if you remember in our matplotlib, so we were trying to create a scatter plot kind of a things. We were trying to plot some scatter plot, and we have seen that we were trying to take a third column as a C, which was trying to give me like a color scale, and based on that accordingly, so it was trying to give a color. So color in a different I would say. So it was trying to give me a color scale, and then it was trying to like show me graph values or color values, color of those dots or those scatter plots in that way. So similar kind of a thing you will be able to observe even in case of a even in case of, I would say, a heat map. So it's completely fine. So you will be able to find out a heat map in this particular way. You will be able to get this particular things in this case. Okay. So here what I'm trying to do is, so I'm trying to call this data. It's just a random data which I'm trying to generate. You can try to generate any other kind of a data as well, which must be having like a X column, Y column, and it must be having a Z column, or maybe you have a relational data set. So on X and Y, so you must be having some other kind of a data. For example, so if I'll try to show you this example. So yeah, I'll come to this graph. So here I'm trying to generate a data, as you can see. So here I'm trying to generate a data. It's completely fine. And I have like a X data, I have a Y data, and then on X0 and on Y0, I have this as a value. Simple. Now, so if I'll try to hold my mouse over here, so it is going to give you like at X0 and Y0. So X0 and Y0. So this is the data that we have. Let's suppose I'm going to store this value maybe inside a variable called as A, and A is nothing but this one. A is nothing but this one, because it's always behave like a random function. So it's always going to create a random data set. So here, if I'm going to give A over here, and it's a 28. So on X0, Y0, we have 28. So you will be able to find out the same data, same values over here. So X0, Y0 is equal to 28. Now, so X0, Y1, so X0, Y1 is equal to 31.72. Similar thing you will be able to find out. So this is how it is going to plot the data. Simple. Now how it is going to decide the color. So color is nothing but, so you will be able to find out it has taken a color scale for a -10 till 16, and depends upon the value. So depends upon the value. So it is going to pick and choose that particular color. So this is how you will be able to understand a color combination and everything, and in the easiest possible way. So that is like completely fine. Color combination is possible, and this kind of a configuration is possible in this particular area. This is called as a heat map. So based on the color intensity, so as we know that blue color is having a highest value, so I will get to know that, okay fine, so blue color is having like a heat map, means it's just trying to show you the color combination, so that you will be able to understand a pattern of the data, that where the intensity is low, where the intensity is very high, or anything as any such kind of a things you will be able to understand. And this is what I'm trying to show you with the help of a heat map in a simplest possible way, in a simplest possible manner. So this is a heat map that we have over here. So it's a very simple thing. And apart from that, so I'm just trying to plot a bubble 3D. Likewise, there are many other things as well that you are going to find out. So here I'm just going to execute a bubble 3D, and a bubble 3D is nothing but it's the same thing. Like I just need the X coordinate, Y coordinate, Z coordinate. Here I'm trying to give size factor. I can try to just remove it, and in this case, so it will be like okay, so bubble 3D, right? So yeah, size column I'm supposed to consider. So here you will be able to find out that it is going to like create a different bubbles, and for every bubbles it is going to give you like a X coordinate, Y coordinate, Z coordinate, just like a scatter plot 3D which I have done just now. So it is just going to give you like this entire 3D structure, and you will be able to observe, you will be able to hover your mouse, and you will be able to perform all those kind of analysis in this particular way. It just need a 3-axis, X axis, Y axis, Z axis. So if I have a data frame, and if I wanted to see that, okay fine, so how this particular row by row data is going to vary, simple, I will get to know that. So this is nothing but row 17, this is nothing but a row 12, this is nothing but row 7, this is nothing but a row 14, this is nothing but row 13. So I'm able to get the indexes, row 6. So simple. So based on that, based on the coordinates, so it is going to perform these kind of operations. So you're just supposed to pass the values, nothing else, and you will be able to get your data set very easily. So this is what happens, guys. Like I told you, there are many more features, there are many more graphs which is available. So you can just keep exploring those graphs, and many things you can try to perform, many things you can try to do. So like I told you, so Plotly is having many different structure which is available. Again, scatter geographical location wise things is also available. So you will be able to find out many more operations. So I'm not sure it is going to work. Yeah, so it always expect a latitude and longitude data set. So geographical data set also you will be able to plot inside a Plotly. It's not tough at all. So like here inside a government website, inside a COVID-19 website, so people was trying to showcase basically a data set based on the geographical location. So that is also inbuilt inside a Plotly. You can try this out and let me know about that. So in the easiest possible way, you will be able to plot it. Like I told you, so apart from geographical location, apart from these things, many other graphs is also possible. So pie plot, candle plot, and then oil plot, bubble 3D, bubble plot, histogram, surface heat map, ratio graph, spread plot, box plot, a scatter plot is a kind of a chart or kind of a graph which is available. Again, like I told you, dashboard wise, there is a enterprise level dashboard which is also like available with Plotly. So they try to sell these things in a market, they try to sell these things as a software into the market. So you can try to use that as well, but I don't recommend like go and explore enterprise version, because even you will be able to get almost every kind of a things into a free version, as simple as that. So you're not supposed to like spend even a single rupees over there. So this is something that I would like to discuss in case of a Plotly. Now moving back to my Cborn. So Cborn is another library, so with which you will be able to plot a different kind of a graph. Now you can tell me that, okay, fine, so which graph I should, you can ask me a question that which graph or which library which I should use. So you can try to use a matplotlib, you can try to use a pandas plot, you can try to use a seaborn, you can try to use a plotly couplings, you can try to use maybe a bokeh, you can try to use maybe a dash, you can try to use maybe a d3js. So there are many libraries which is available into a market. It depends upon us. So it depends upon like if I like, because previously I used to like a matplotlib and seaborn, but nowadays I'm liking this plotly actually a lot, because of its feature functionalities and a different kind of facilities. So it depends upon me actually, like what I want. So what kind of a plot I'm looking for, whether it should be interactive or whether it should be a static or something, and based on that I can try to use. Function wise, as far as functionality is concerned, I think if you are able to understand one library, you can understand any libraries. No functions, you are not supposed to remember even a single function at any point of a time. It's completely fine. You can like try to use these functions. You can try to like keep on learning these functions on a ad hoc basis. You will be able to get it. Someone is saying that they are not able to find out a folium package. Just remove it. You don't need that folium package. Just remove it and then try to install it. It's completely fine. So fine. Now, people who are working into a Google Colab, don't try to work on a Google Colab. It will give you an issue. So just try to execute it in a local system. That will be better. Now here, so I'm trying to use like a Seaborn library. As you can see, Seaborn is another kind of a library which will try to give you a flexibility to perform different kind of operation. So that is possible, I would say. So here in this particular case, in case of a Seaborn, so again, I'm trying to load some of the data. So some of the data which is already available inside a Seaborn library. So I'm just trying to use this Seaborn library, and I'm just trying to load a data over here. And after loading a data, so I will try to perform some kind of a operation. So here I'm just trying to load a data which is called as a tips data. So whenever we go to a restaurant, so we try to pay a bill, we try to give a tips, and yeah, this is what we do. So there is a data set called as open source data set, which is called as a tips, which is available. So you can like try to go through this tips data set. You can try to download this tips data set as a CSV, or else these data set is also available in a Seaborn library. So you can directly use it, or else you can try to download as a CSV, and then you can try to use it. So fine guys, here I'm trying to like load a tips data set. It's completely fine. And then on top of that, so I'm trying to call a Seaborn dot relational plot, and X is equal to total bill, Y is equal to tips. So in this one, so you will be able to find out that I have a multiple column, like a total bill column I have over here. This is a total bill column, and I have a tips column. It's completely fine. Now, so I wanted to see that what is the relationship between our tips and a total bill. So I'm just trying to call a Seaborn. This is a Seaborn alias for Seaborn dot relational plot. So this is basically a relational plot. It will try to show you a relations in between, relation of a kind of a line, or maybe relation of a kind of a scatter plot or something like that. It will try to show you. And then here I'm trying to give my x-axis value, which is nothing but the total bill column, and my y-axis value, which is nothing but a tips. So here I'm just trying to perform this operations. So data is equal to tips, data is equal to tips. So this is the tips data which I have loaded. So I'm just trying to give a data frame name over here, nothing else. And here you will be able to find out some kind of observation. So total bill versus tips. So this is the plot which it has done. So it has taken this coordinates, 1 coordinates, and then it is trying to perform this kind of operations for me. So that is like completely fine. I'm able to get my scatter plot kind of a graph by default. And here I'm able to see that, okay, so like a highest bill wise, this is the person who has paid a highest bill, and this is the same person who has given the highest tips. Most of the person so has paid a bill in between 10 to $30, and their tips was around in between $1 to $4. So this is the kind of insights that you will be able to get just by looking into this data. This is nothing but it's same as a scatter plot that we have done inside a matplotlib, or same scatter plot that we have done inside a, I would say, like a plotly So it's nothing fancy, it's nothing new for any one of you. So it's the same thing that we have done so far, so forth. So fine guys, what I'm going to do over here is now, so I'm just trying to like plot these graph, and what I would like to do over here is I wanted to check some kind of a controls. So let me remove as of now a style. I'll try to add it in a later stage. So here I'm trying to call cborn dot relational plot. X-axis is equal to total bill, same data, and y-axis is equal to tips, same data. Now data is equal to tips data set, and hue is equal to a smoker. So hue basically try to change a color. This is what has been, this is where a hue is been used. It always try to control or change the colors. So now if I'm going to execute it, so you will be able to find out that previously I have the entire data set with a single color, but now these things had changed. Now inside a hue column, so what we have passed a smoker. And if you will look into the data set, so you have basically a smoker column. So there are two values, two pairs which is available inside a smoker. One is a yes and one is a no. Means yes smoker and no smoker. So these are the only two values which you will be able to find out in this particular place, I can say. So hue. So whenever we are going to set hue is equal to a smoker over here. So hue is equal to smoker whenever you will be able to find out over here. So you can see that, okay, fine. So there is a yes smoker and there is a no as a smoker which has been given. Now so yes is going to like take a blue color, and no is going to take a orange color, as simple as that. And here, so if I'll ask you a question, that a person who has paid basically a highest bill and highest tips, so that person was a smoker or that person was a non-smoker. So this is the person, this was that person who has paid a highest bill, and you can clearly say that yes, blue is representing basically a yes smoker, and orange is representing no smoker, means person who don't smoke. So you, yes, so that person was actually in a smoker, so it's a blue color, so it's actually in a smoker. So this is the additional information you will be able to add with the help of hue. So hue is a parameter. So if I'm going to pass some column over here, so it depends upon the total number of the category which is available inside this column. So inside a smoker column, I have yes and no. These are the two category. If I have more number of category, it will try to create that many number of the colors, and then it will try to represent. Means I'm simply trying to group the data set based on yes and no, and then I'm trying to represent. So group yes will be represented by a blue color. So and group no, it will be represented by a orange color. As simple as that. This is how you will be able to understand it. So hue always controls a color. Now on top of that, so control gel. So I'm trying to talk about like a style. So what is a style? So style wise, I'm trying to give like a time column, as you can see. So time is another column. So there is a two kind of a time which is available in this data set, which I'm using, a dinner time and a lunch time. So here what I can do is, so I can try to execute it, and this time, so what happens is style. So if style is another parameter, so hue always try to distinguish between a data set based on the color. So it try to create a grouping based on the color. Now if I'll talk about a style, so a style always try to like do a styling. So style always try to do a styling, so based on the sizes, based on the size, so it try to perform the styling operations in this particular way. So as you can see, we have like a lunch and we have a dinner. So lunch is been represented by a circle, and dinner is been represented by basically cross. Now if I wanted to know that person who has paid basically, so that person who has highest like a person who has paid like a highest tips and highest bill was basically smoker or non-smoker. Yes, we are able to find out that that person was basically a smoker. Plus I wanted to know that that person came for a dinner or that person came for a lunch. So here is a cross that you are able to find out, and cross is basically a notation for what? A dinner. It's a dinner basically. So lunch is been represented by circle. So you will be able to find out even if I'll try to pick and choose this data. So I can say that, okay, fine. So this person actually came for dinner and this person is a smoker. If I'll talk about this one, so you can say that, okay, fine. So this person actually came for the dinner, but this person was non-smoker, because orange color and cross. So cross means dinner, orange color means no smoker. These are the idea that I will be able to get. Now, so if I'm going to pick and choose this one, so you can say that, okay, fine. So this person is a non-smoker, and this person actually came for what? Came for lunch, because the circle. So this is how you will be able to like create a group inside a group inside the group inside the data, and then based on that you can try to get a very clear understanding and idea about the trend of the data set. It's very easy. Now if I'll ask you that, okay, fine, so like just by looking into a graph, so what is your observation says? So whether people what is the majority of the like what is the majority, like whether we had a more number of smoker or whether we had a more number of a non-smoker. So you can clearly say that we have more number of a orange dot and crosses, so we have more number of a no smoker as compared to a smoker. So yes, even this says the same thing in this particular case. So okay, so in this particular case, this is how you will be able to find out. Fine. Now, so here I'm just trying to load my tips data set, and fine. Now here, so I'm just trying to load a tips data set, as simple as that. And then on top of that, so what I'm trying to perform. So again, same thing. So I'm just trying to perform some kind of operation. So we talked about basically a color hue, which is responsible for a color. And here you will be able to find out styling. So styling is nothing but, so again, same thing. It try to give you a different different kind of shapes or different kind of a size. So it depends upon the number of the groups which is available. So last time I have done style is equal to time. So inside my time column, I just had two kind of a groups. One is a lunch, one is a dinner. This time I'm trying to perform this styling, but in this time I'm trying to give a size column where I have a different kind of sizes. So here you will be able to find out that if I'm talking about, or if I have a different kind of a sizes, so size is equal to 1, size equal to 2, 3, 4, 5, 6. So it's been represented by a different kind of symbols. So different size are different symbols, which is which it is trying to represent. So again, I'm just trying to perform a grouping operation, you can say. So like a size 1, I'm trying to perform group as a circle, or maybe size 2, I'm just trying to perform group as a cross, or like a square. So I'm trying to perform a group as a size 3. So I'm trying to perform a group as a square. So as simple as that. So it's just been used for the grouping operation, nothing else. Again, inside a hue column, so I'm trying to give a size. So it is always trying to take like a pair. So 0 to 2, 2 to 4, 4 to 5, 4 to 6, 6 to 6 and beyond. So it is trying to create again a color, because I know that hue is responsible for a color. So it is just trying to take a colors, and then based on that, it is trying to represent it. Now, if I'll ask you a question that, okay, so there is a person, so there are a person who is coming to our restaurant, and what is a size of the groups who comes to our restaurant? What is the majority of the size of the person who came to our restaurant? You can say that majority is nothing but, so it is trying to represent it. It is representing by this color. Majority of the data set has been represented by this color. So you can say that the mostly people are coming in a group of two. You will be able to find out. So just by looking into this observation, because this is what a hue says. This is what it says in this particular place. So it's completely fine. This is what you will be able to understand. Now here's what I have done. I have taken all those things at the same time. So hue is equal to smoker, so it will try to perform a grouping operation based on the smoker. Then style is equal to time, and then size is equal to size, which I have taken. And here you will be able to find out that somewhere we have a little bit bigger size, somewhere we have a smaller size, and based on that, so it is trying to represent my entire data set. Nothing else, nothing fancy. Now, so yeah, it's the same thing. Here I'm just trying to generate some random data. That's it. So I'm trying to generate some random data over here. And here, so I'm trying to call SNS dot relational plot, and X is equal to time column. So here I'm trying to generate a time data as well as value. Simple, like a two data, like a two column I'm trying to generate inside a data frame. Then on top of that, so X is equal to time axis time column, and then Y is equal to value. This is what I've given. Now kind is equal to line. So I'm trying to like look for the line plot. Line plot is nothing but line plot is basically if I'm going to remove it, so by default it is going to give me a scatter plot. So line plot is nothing but it's just a line, connecting line to each and every dots. So whatever data you will be able to get inside the scatter plot, so line plot is going to perform, just a line plot is going to add each and every data set, and then it is going to give you a final result. As simple as that. So this is this thing, well, this is a combination of each and every dots. Now here, so what I'm going to do is, so I'm going to like create a data frame, as simple as that. And then again, I'm trying to like plot it. So relational plot, X is equal to time, Y is equal to value, kind is equal to line plot I'm trying to perform. So it's nothing but again, same thing. So it will try to scatter the data, and then it will try to connect all the data set. That is called as a line plot. Data is equal to data frame, sort is equal to true, means once after sorting the data, so it is going to perform these operations. Now here, so I'm trying to load another set of a data. So that is called as a Fumry data set. So Fumry is again a open source data set which is available inside a Seaborn. You can try to load a data set CSV, and then you can try to perform this operation. Or else what you can do is you can try to like call this data set from a Seaborn library itself, the way I'm trying to do. So here I'm trying to call like a Fumry, and then SNS dot relational plot, and the x-axis is equal to time point, and y-axis is equal to signal. So x-axis is equal to time point, and then y-axis is equal to signal. So this is something which I'm trying to give over here. Data is equal to Fumry, which I'm trying to give. Now, so after giving this kind of operation, so whatever like data set say that I had, so it is trying to plot it. Simple. So it's a normal scatter plot, because we always know that relational plot by default is going to perform a scatter plot operation. So even if you are going to check, so kind is equal to like here, so kind is equal to scatter, you will be able to find it. So by default, anyhow, it is going to perform a scatter plot kind of a operation. So it's completely fine. I'm able to get a scatter plot kind of a things, a scatter plot kind of operations over here in this particular place. That is not a problem. Then so Seaborn dot relational plot, and then X is equal to time point, Y is equal to signal, kind is equal to line. And here, so let's suppose if I'm going to change these things, let's suppose if I'm going to make kind is equal to line, Control Z, and then kind is equal to line. If I'm going to give, you will be able to find out that it is trying to draw a line with respect to the same shape that we were able to get into a scatter plot. And then so on an outer on an outer, I would say a perimeter, so it is trying to draw some kind of a shadow lines just to represent a shape. That's it. Like, okay, fine, so I have a data set, and then it was expanded till certain points. Now what I'm trying to do is, so I'm trying to basically like give ci is equal to sd. So if I'm going to give ci is equal to sd, so what it will do is, so it will try to find out the standard deviation of the data set. So how my data set is deviated from the middle line, because middle line is representing what? It is representing a mean of the entire data set. So it will try to draw this kind of a shadow based on the standard deviations value. So whatever standard deviation of this data set you are going to get, so based on that, it is going to draw the shadow. So both of the line is completely same, and this has been represented based on your scatter plot itself. But here, so width wise, it is going to take a standard deviations, nothing else. Shape wise, it's not going to change at all, because I'm trying to consider just like a same old data with the same old graph. Now here, so again, I'm trying to perform a relational plot, and I'm trying to perform a relational plot based on the Fumry data set. So I have basically a Fumry here. Okay, so I have a like a time point, and I have a signal, and I'm trying to select it. Estimated is equal to none. So I'm just like even if you are going to remove it, okay. So here, you will be able to find out that x-axis is equal to this one, y-axis is equal to this one, kind is equal to line, data is equal to family. Now, so it is going to give me same old kind of a line. Now, if I'm going to make estimator is equal to none, then what you will be able to find out. So in this case, what you will be able to find out is, so it will try to give you this kind of a graph. It will try to give you this kind of a graph. So it will be a same graph, but estimator is equal to none if we are going to give. So it will not try to estimate anything by itself, and this is something that you will end up getting. So this is something that you will end up getting. So it's the same graph. If you remember the shape of the scatter plot of this graph, so it was same actually. So its shape was exactly same. It was not changed at all. And this was a line plot which I was able to get. So this is a completely same, but what happens in this particular place is, so it is going to just like try to take, I would say, estimations or fluctuation. So in a previous one, so in a line plot, it tried to take the estimation. When I'm trying to set estimation is equal to none, so in that case, it is just going to fluctuate, or it is just going to show you a line across the entire shape or across the entire points. Simple as that. So the next one is, so again, I'm trying to like distinguish, I'm trying to create a group of the data set. So as we know that based on the hue or based on maybe a style, I will be able to perform a size. So hue, style and size, based on these three parameters, I will be able to perform a grouping operation, because this is what we have seen. So hue is responsible. Hue always try to represent a data set in a different groups based on the color. Style, so it try to give you maybe a circle or maybe a cross or maybe a boxes, and based on that it try to group the data set. Size is nothing but, so it always try to consider a column values, so whatever value is been given, and then it will try to like perform the sizing operation, and it will try to take like some ranges in between, and based on that, so it is going to give you a sizes. So again, we have something called as a kind is equal to line which has been given. So so we all know that what is the meaning of a kind, so we are not supposed to talk about that again. And hue is basically an event. So event is what? So event is stem or queue. These are the two events. So basically it will try to group the data set based on the stem and the queue. So these were the only two value which is available. So it is just trying to like group the data set based on the stem and the queue, and then finally I'm able to get these two graphs. So group one, group two, group stem, group queue. If I'm going to remove this line, so it's nothing but it's the same old graph that we have seen. So it's the same old graph that you will be able to see, like a dotted line. But whenever we are going to give kind is equal to line, so it always try to take estimator, and then it will try to draw the line for the orange and for the blue. So this is the reason I'm able to get this line graph for the same thing, but both graph is completely same. There is no differences that you will be able to find out in between. Now, so let's try to understand, or let's try to find out that what this formula is going to give. Okay, so here SNS dot relational plot you will be able to find out, and I'm trying to do like a hue. So based on hue, so it is going to distinguish between the data set. It will try to separate our data set that is true, that is completely fine. Now, so style wise, so I'm trying to give style is equal to event. So as we know what style does, so style is always going to create again like a styling. So style is equal to event. So it is going to create a different style. So as you can see, style wise, it has grouped my data set, and then again kind is equal to line, data is equal to family. So style wise, basically I've given event column. So stem and queue, it has given me a continuous line and dotted line, and hue is equal to reason. So we has a partial and we had a frontal. It is trying to give, or it is trying to represent a colors, nothing fancy, nothing much. So here I'm able to get this kind of a graph. That's completely fine. So we have just created a 4 pair of the groups based on the reason and event. So based on hue and style. Now, so this is the data set which I'm trying to generate. Again, I think we talked about a pandas or trade range in our previous classes, and we talked about even random functions. Now, so here I'm trying to create again a relational plot. And let's suppose if I'm not going to give this, I'm just going to give this one. So in this case, what you will be able to find out that I had a date. Actually, I had a date on a first column, which is which I'm trying to represent on a x-axis. So if I'm trying to represent a date, so as we know, date is a long word, or long it is going to take a more amount of space. So here what will happen is, so it is just going to like give you a date range, and suppose if I wanted to represent this date into a beautiful way, so in a human readable way, so what I should do is, so I can try to create this graph. It's a very simple normal graph, the same graph that we have done. And here, so the graph object dot fig dot auto format x date. So you will be able to find out that it is trying to automatically format your dates, and now it's available into a human readable format. Likewise, there are many more other features and functionalities which is available, but yeah, this is one of the functionalities that you can use and then you can avail at any point of a time. Now, the next thing which I will be talking about is like, I'm trying to load this tips data set, and hue is equal to this one. Now this time column is equal to time. So I am trying to introduce another variations over here, column. So suppose if I'm going to call this data, so time wise we had two data, dinner time or lunch time. Suppose if I wanted to separate these two data, so dinner is separate and lunch is as a separate. So in that case, what I can do is, so I can try to call like a column is equal to time, and then it is going to create two number of column, one for lunch time, one for dinner time. Again, it's a grouping, separate like a graph itself. It is going to create based on the column is equal to like time, so lunch time, and for the return time. It's very simple, and rest of the thing is very same. Now, so here column is equal to size I have given, and inside a size, so I have a 6 variations inside a size. So basically I had a 6 variations. So what it will try to do is, so it will try to like create that many number of the graph, and as you can see, it's very small. It's I'm not able to visualize it. I'm not able to look into these graphs properly. So what I can do is, column is equal to size I will give for sure, but column wrap is equal to 2 or column wrap is equal to 3 I will try to give. Means, so at a time it will try to take only 2 columns, because size is going to group, size is going to create maybe a six number of groups. And here if I'm going to give column wrap is equal to 2, so in a single column it is going to give only 2 groups. That's it. So 2 separate groups, size 1, size 2, size 3, size 4, size 5, size 6. So this is what happens. Height is equal to 3 is nothing but just representing the height of the entire graphs. That's it. So this is again a useful operation for visualizing a data and separating a graph, column and a column wrap operations. Again, no need to remember anything, just need to know that, okay, fine, so this kind of a things which I can do. Now here, so again, I'm trying to like perform what? So till last time I was trying to do a relational plot, right? And there is a separate function which is available called as a scatter plot. So even with the help of a relational plot, I was trying to like do a same kind of a thing. And with the help of a scatter plot, I will be able to do a similar thing. There is no differences that you will be able to find out in between in terms of a representation of the data set. Both works fine. So either you can go ahead with the relational plot and then you can pass your X and Y value, or else you can try to go ahead with the scatter plot and then you can try to use it. In both the way, you will be able to get the same result. Now, summary head, I'm trying to load Irish dataset. So I think we talked about Irish dataset even in our last class. So inside our Irish dataset, so we have a sepal length, sepal width, petal length, petal width. So it's completely fine. So here is our Irish dataset, and yes, I'm able to get sepal length, sepal width, petal width, and a species. Now, so I can try to perform a scatter plot operation, and this is the same old graph. I think all of you remember that this is the same graph that we have plotted. So sepal, so variations in between our petal length and sepal length. This is the same thing that we have done in our last class, and it's completely fine. We are able to do this as well. Okay, so I'm just trying to show you like an example of the scatter plot, nothing else. A scatter plot as a function which is available. If you are not able to remember it, even I don't remember all those functions. That is completely fine. So if you are not able to remember it, you can just leave it. You leave it aside, and simple. You can just try to use a relational plot, and with the relational plot, you will be having all kind of a control with every kind of a graph, every kind of a data set. If you are going to use a CBOL. So again here, so categorical plot, so tips data set I'm trying to load. So same old data set, and Titanic data set I'm trying to load. So I think we are aware about a tips data set as well as we are aware about a Titanic data set. So we are just trying to load this data, nothing else. And then categorical plot is nothing but, so whenever you have some kind of a categories data, means string data set, and if you wanted to perform some kind of a plotting operation, so you will be able to perform those kind of plotting operations with the help of a categorical data set. So here what I'm trying to do is, so I'm trying to call sns.categorical plot x, y, and then data. So here x-axis wise, I'm trying to give day. So I'm trying to call a tips data set. So tips data set, and then I'm trying to give day in a x coordinate. So it's completely fine. So there is a day in a x coordinate. It's completely fine. And then in a y axis, so I'm trying to give what? I'm trying to give total bills. So total bills is nothing but, so this is the total bills. So day versus total bills means on what day, what was the total bill? This is what I'm trying to represent. Simple. So here you will be able to find out that this is the first graph that I'm able to get. Now, if I'll ask you a question that, okay, on what day, so I have done a exceptional business or I have done a better business. So you can say that, okay, on Saturday, I have done a better business because on Saturday, so total bill was going almost like till $50, right? And then if I'll talk about a Sunday, so on Sunday, so yes, there was a business, but yeah, it was lower than, I can say like, lower than Saturday. And if I'll ask you that, okay, fine. So on which day? So you were not able to do a very good business. You're like, people was not visiting your restaurant. So in that case, I can say that, okay, fine. So on Friday, so I was not getting much customer. So this is a kind of analysis, or this is a kind of insights that you will be able to find out with respect to a data set in the easiest possible manner. That is completely fine. So in this case, now here, so here what you will be able to see. So if I wanted to flip this data, if I wanted to flip this graph, so what I can do is I can try to make x-axis as a y-axis, y-axis as a x-axis. So this is how I will be able to rotate my graph, and then I will be able to get this particular observation. Now the another thing is, there is a parameter called as jitter. Again, this is like a parameter which you should not remember all the time. So there is a parameter called a jitter. Jitter is nothing but, so whatever graph that we are trying to plot over here, so instead of showing all the data, it will just show you the linear data, just one line it will try to show you. Means it will just try to show you in terms of a height, that's it. So this is called as a jitter. So jitter has been derived from the same one, but jitter always try to show you just one single line, that's it, nothing else. Now there is something called as a swarm plot. So swarm always try to give you a flower kind of a plot. Like again, it's a fancy graph, but maximum time you will be able to find out that it is of no use. But yes, this is something, this is some fancy graph which is available inside a C1, and that's the reason. So I'm just talking about it. I just wanted to like discuss the things with you, so that you will be aware about these facts, that okay, fine, so this kind of a fancy things is available. Maybe in a future, so at some point of a time you might need these fancy things, maybe you can try to use it. So keeping these things in our mind, so we are like trying to talk about this particular one. So here I'm just trying to use this these things in this particular place, nothing else. Now, okay, so this is the fancy thing which I'm trying to use. Again, what I'm trying to do is, so I'm trying to perform a categorical plot, cat plot, and I have given x-axis is equal to smoker. So a smoker means yes or no smoker, and tips. So tips versus smoker. Like I wanted to observe that, okay, so who has given like a more amount of a tips. So whether it was a smoker or it was a non-smoker or something like that. So I can say that, okay, fine. So yes, there was a smoker, so who has given a maximum amount of the maximum tips. And there was many people who has given a tips, those belongs to a non-smoker category. It is, this graph looks more dense as compared to this particular graph. So this is how observations you will be able to do it. Now, so smoker and everything is fine, but I think I talked about a box plot. I talked about a box plot into a matplotlib, and I was telling you that box plot has been used to perform a outlier detection. By default, it will try to give you an outliers. Outliers is something which is beyond a quartile range, or beyond like so as I have discussed, that this point is nothing but it's a maximum, this point is nothing but it's a minimum, this point is nothing but it's a Q1, this point is nothing but a Q2 or medium, this point is nothing but it's a Q3. So quartile 1, quartile 2, quartile 3, and this is nothing but it's a IQR, interquartile range. So same thing is applicable whether you are going to talk about this like this box plot in a pandas, Python, or maybe into R programming, or maybe into a Tableau dashboard, or maybe Power BI, or maybe anywhere. Meaning is not going to change at all about this box plot or any other graph which I have discussed. So if you know one kind of a graph, you will get to know other kind of a graph as well. And you can just try to use any libraries that you want. Meaning wise, it's completely same, each and every graph, like a line plot or a scatter plot or matrix, or maybe a heat plot, scatter matrices, box plot, swarm plot, violin plot. So these things are not going to change at all. This definition never changes actually. So yes, a library or functions is going to change, some parameter is going to change, but these actual definition never changes. So here you will be able to find out that it is going to represent a maximum, and as we have discussed, a formula for maximum is nothing but a Q3 plus 1.5 times then IQR. Minimum is nothing but, so again I'm just going to repeat it, Q1 minus 1.5 times then IQR, and then Q1 is nothing but, so 25th percentile. Now, so I'm assuming that you all are very much clear with a 25th percentile. It's not a 25% of the data. It's a 25th percentile. It's 25th percentage of the indexes of the data. Now, so Q3, Q2, I can try to represent as a median or like a 50th percentile. And Q3 is nothing but, I would say, like 75th percentile. This is how this entire point is been represented in our in our box plot. Now the data, like I told you, so data which is beyond the maximum, and this is how maximum has been calculated. So the data which is beyond this calculation is considered as a high outliers, and data below this calculation is considered as a low outliers. So if you have a data, and if I wanted to know that, okay, so what in all outliers I have, right, in what column, so that I will be able to treat those columns, I will be able to remove those outliers. So I will be able to get those informations based on, so I will be able to extract those information easily, I can say very easily, I would say, based on these histograms. So this is something that I will be able to get very easily. Maybe I can try this out. Maybe I can try this out with respect to the same data set in my plot. Let's try to understand it. So here what I can do is I can try to call a same data. So this is nothing but a tips data that we have. So what I can do is I can try to call my tips data set. Okay. So I can try to load this tips data set into my plotly, and let's see so how it is going to behave with respect to a box plot. Okay, so here is my box plot, and here I'm going to create a data. So tips.head, and that is completely like a fine. And what I can do is, so I can try to perform this box plot kind of operation. So let's try to understand. So suppose if I'm going to give tips over here, so let's see how it is going to perform. So as you can see, so this was the total number of the column which was available. So for all the numerical value column, so for all the numerical column value, so it is trying to perform these kind of operations. So it is just trying to perform this kind of operations. And for the total bill, so yes, it is giving me this kind of a graph. And for tip column, so it is giving me this kind of a graph, and for the size column, so it is trying to give me this kind of a graph. So whatever categorical data that we had, so for sure for that it is, so whatever column was having like a categorical data, so you can't create a 75th percentile or minimum or maximum or median. So yeah, for the categorical column, like a 6 column, it was a categorical smoker column, it was a categorical day column, categorical time column, it was a categorical, so it is not going to give you any kind of a graph. Now, so here what we were trying to do is, so Control F and BOX box plot. Now here I was basically trying to provide, so here actually I'm trying to provide just a day-wise data. So I was just trying to provide a day-wise data. So here it was like x-axis is equal to day and y-axis is equal to tips. So it's completely fine, not an issue. So even I can try to provide day-wise data. over here. And based on that, so I can try to like perform this kind of plotting operations. So by giving x-axis and y-axis with respect to day wise. So you can just try this out, and whatever graph that we were able to get in case of a Seaborn library, I will be able to get a exactly same graph. It is taking some time to load. That's completely fine. So you will be able to see an outliers. So as of now, so it's completely fine. My bill is normalized, my size is normalized, and my tips is normalized. So that is completely fine. It is not going to give you any kind of a issue. But if it is not a normal data, so in that case, for sure, it is going to give you an issue. And in that case, what you are supposed to do is, so you can try to like get to know that, okay, fine, so what are all outliers we have. This data output is never going to change for any kind of a data that you are going to use. Everywhere you are going to get a similar kind of a graph. The only thing is interactiveness, so you can change our interactiveness accordingly. So it's completely fine. I'm able to get that one, and it's like a box plot. And here you will be able to find out a Boxen plot, Boxen actually. So there is a something called as a box plot. There is something called as a box and plot. Both is almost like a same. Both try to represent a similar kind of a things. The only difference is that you will be able to find out in terms of a some kind of a shape, some kind of a shape. So both represent like a Q1, then a Q2, then Q3, then maximum, then minimum, then IQR. Everything is same. So I always like try to plot this box plot instead of doing a box and plot. Little bit like a fancy for me. And then there is another graph which I'm trying, another data which I'm trying to load. Again, it's an open source data, which is a diamond data set. So I'm just trying to load it, and then I'm trying to call like a seaborn dot categorical plot. X-axis is equal to color, and then price is equal to y-axis. So color is nothing but E, J, I, and all those things, and price nothing but numerical data. So categorical versus numerical. Simple. I'm trying to plot it. It is again a Boxen plot, and Boxen plot is almost close to or almost similar to a box plot, but the graph that it try to give you, like, it's a little bit different. Now, so here I'm trying to perform like a SNS dot categorical plot, and again it's a Boxen plot, same thing, same thing. There is another graph called as volume plot. I think like it's a kind of a useless graph sometime, because I never used it in my real-time data analysis. I would say it's not used frequently at any point of a time. So just like a fancy kind of a graph that you will be able to find out. So it's always trying to represent data in terms of volume. That's it. That is called as a volume plot. But yeah, if you are going to plot some data like based on this fancy stuff, so you can do that. Now, if you remember that we were trying to plot one graph inside other graph based on the axis, even inside the matplotlib. So here what I'm trying to do is, so I'm trying to create one graph, as you can see. So I'm trying to create one graph over here, which is nothing but, which is the volume plot. I'm trying to create it, fine. Now the second graph which I'm trying to plot over here is nothing but it's a swarm plot. So here I'm trying to perform a swarm plot operation. So yes, it's a swarm plot which it will be able to give me if I can remove an axis. Okay, so this is the swarm plot and this is the volume plot. Let's suppose I wanted to combine both. If I wanted to plot both the data, both the graph in similar way, so I can, so in the same axis. So I'm trying to store this graph into some variable, and then axis is equal to what? Axis of the same object, same graph object. And in that case, I will be able to find out, in this case, I will be able to find out that it is going to give me this as a final graph, this as a final data, it is going to give it to me. So it's completely fine, guys. Like I'm just trying to combine these two graphs, just like I have combined two graphs in our matplotlib, like a matplotlib example. So the similar way. Now it's a Titanic data set which I'm trying to load, and then as a categorical plot, I'm trying to perform like kind is equal to count plot. So count is nothing but it's almost close to a bar graph. You will be able to find out. So X is equal to deck, and if I look into a deck column, I have like a ABC kind of a, or NN kind of a thing. Now, so A, B, C, D, E, and all those things I have now. So palette is nothing but, so it is going to control a colors. It is going to control a colors actually. So if I'm going to give like a 0.2, or maybe let's give 0.9. It's just trying to control the color, nothing else. So it is just trying to control the colors in terms of palette. Now data is a titanic, hue is a class. So based on the classes, just try to separate these things into two major colors. So fine. So we have like a first, second, and third. These are the three classes. So it is just trying to represent it. On a x-axis, it is representing just column groups, and then or like on a y-axis, so it is just trying to represent that. Okay, fine. So how many data set we have in a column or like in a A? So A is basically deck. So in a deck A, how many data set we have? In a deck B, how many data set we have? In a deck C, how many data set we have? In a deck D, how many data set we have? And again, so on top of that, so we are trying to separate these things with the classes. So we had basically like a third as like a first and second class data in a deck D. In a deck E, we have first, second, and third, all three classes. In deck F, so we had basically like a second class and the third class. So this is how you will be able to find out, and this is how you will be able to understand these things in a easiest possible manner, I would say. So fine guys, this is like how it actually works, this particular graphical representation. And then what I'm trying to do is, so I'm trying to like visualize a data distribution. So here I'm trying to create a random data, let's suppose. So let's suppose I'm trying to create a random data. So np.array, and here let's suppose if I'm trying to create 100 data set. Now if I'm going to execute it, so np.array 100 left, length is unsized. Okay, distribution plot. Not defined. Okay, so here what I'm trying to do is, so I'm just trying to like create some kind of data, and I wanted to show you that how distribution plot actually works. So what is the meaning of distribution plot? So distribution plot is a kind of a data which will try to show you that whether your data set is normalized or your data set is not normalized. This is what it will try to perform in this particular place. Now, so here what I can do is maybe I can try to pass some data. So it is not working. Let me check. A 1D array or list. Okay, that is fine. So I'm trying to provide a 1D array. That's fine. This is basically like a 1D array. If I'm going to print A, okay. numpy.random.rand I can write, and then 100 random data I can try to create. Now it will work. Yeah, see what happens over here. So I'm trying to write like a numpy.random.rand. I think we all are aware about this function. I'm trying to create 100 data set. Now, so as we all know that rand function always try to create a normalized data set, means whatever data set it is going to create. So that data set, so if I'm going to remove everything, let's suppose if I'm going to remove everything, so this is how it will look like. So here what will happen is, so it always try to create a random data set, and the entire data set will be a normalized one, means it is going to form a bell-shaped curve. Now here I have created like a 100 data set, and I wanted to know that whether this data set is normal or not. If it is not normal, so we try to treat those data. So this is how we are going to perform this operation on every columns as well. So every columns of the data set, we are going to perform this kind of a operation. So here I'm trying to call like a SNS dot distribution plot. I'm trying to pass this data so that I will be able to understand that whether this data set is standard or normally distributed or not. And if I'm going to do so, if I'm going to perform these kind of operations, so yes, I will be able to find out that this data set is almost like a close to the curve or close to the normal. But if I'm going to like increase the data, so increase the data, so in that case you will be able to find out that random.randn, let's suppose, let me use. So you will be able to find out that it's almost giving you a data set which is close to or it's like a perfect, I would say, perfect shape of the, like a bell curve it is going to give you, or normal distribution curve it is going to give you. So yeah, this was the same definition that we have seen and we have studied in case of a numpy. So it always try to give you a data set with the standard normal distribution is equal to so with a standard normal distribution where mu is equal to 0 and standard deviation is equal to 1. And yes, I'm able to get a same kind of a things even in my observation. So distribution plot is nothing but it always try to give you a distribution of the entire data set. Now how it is going to calculate an y-axis? So to calculate a y-axis, as I have already given you a formula even last time. So y-axis it try to calculate based on this formula. So root of 2 pi rho 1 by, so e to the power minus of 1 by 2 x minus mu by rho of square. So these things I will be talking about in your stats class, not now. So in a stats class, I will be talking about like what is a normal distribution, what is a random normal distribution, what is a standard normal distribution, and then I will be talking about this formula. So how it is going to create this graph, how it is going to create a points, because to create this graph, right, I need 2 points. I need a x coordinate, I need a y coordinate. X coordinate is already given. X coordinate, suppose randomly I'm trying to generate, but where is my y coordinate basically, and how it is going to give me this curve. So all these things will be try to understand in our statistics class for sure. Now so there is something called as a joint plot. So joint plot is nothing but, so combinedly it will try to plot two graphs altogether. So here I'm trying to perform a joint plot, and x-axis is equal to tips, total bill, and y is nothing but tips basically. So these are the two columns which I have taken. So joint is nothing but, so as you can see, total bill versus tips. So this is the scatter plot it is trying to perform. And then here, so it's a histogram for what? Total bill. And this one is basically a histogram for what? A tips, as simple as that. So histogram also represents a normal distribution, as we know. So if we are going to combine these points, so it is going to represent normal distribution. So you will be able to just check that, okay, fine, so whether my total bill is normally distributed or not, or whether my tips is normally distributed or not, or we have a spikes or something like that. So I will be able to get to know. Based on that, maybe I can decide that my restaurant is stable or my restaurant is not stable. So joint plot always try to perform this two plot operation altogether. So here also I'm trying to perform a joint plot. Kind is equal to hex, which I have taken, so it's completely fine. Hex we have taken in this particular place. And yeah, so if you remember, so we have discussed about a scatter matrices, right? We talked about a scatter matrices in our very first visualization class. And here, so you will be able to find out a pair plot. So exactly, the graph is exactly the same. So if you have seen, or if you remember that graph that we have discussed in that class, it's exactly a same graph that we are talking about even over here. So in this particular place, so it's a pair plot which I'm trying to perform. So pair plot wise, so I'm just trying to create a pair. So every column versus every column. So I'm just trying to compare every column versus every column in this particular case. Now the another graph which I'm trying to draw over here is a linear regression plot. So it always we are going to learn these things in a very first class of your machine learning, that how linear regression actually works, and how what is the meaning of y is equal to mx plus c, or maybe dy by dm, or rate of change of dy by dc. So all those things we will try to understand for sure in our machine learning classes, how actually learning happens. But here, so what it will try to do is, and again, so and after that you will be able to understand these things in a better way. So after that you will be able to understand it. But here you will be able to find out that in a lm plot, means a linear regression plot basically, so it is trying to draw, or it is trying to show you a total bill versus tips, that is fine. But even on top of that, so it is trying to intersect a line, or it's trying to find out the best fitted line. So based on the best fitted line, so it is trying to best fitted line with respect to the data set. So maybe this best, what is the best fitted line, how many lines it try to find out of that, what is the selection it is trying to do, or what is the meaning of this shadow. All those things you will not be able to understand as of now, unless and until I'm not going to discuss about a linear regression. So then you will be able to find out that how it is plotting this line. So what is the meaning of this best fitted line it is trying to plot, and how it is, and why I'm saying that it's a linear regression, means it's a linear relation basically. So you will be able to find out everything. But even into a C-ball, without applying any algorithm, it is possible to find out a best fitted line, or it is possible to find out, I would say, like, or maybe a regressor line. So this is what you can say into a CBON. So there are many more functionality. There are many more things which is available inside, like pandas or matplotlib, or a CBON, or maybe a plotly couplings, maybe a bokeh, maybe a D3, maybe a dash. So there are, like I told you, there are many libraries which is available in this world, and you can try to use any of these libraries. No one is going to stop you. Generally, we try to use max to max, like same common graphs to understand and analyze a data. So you can just feel free to use any of these things, and based on that, you can try to explore each and everything. So this is it from my side, guys, for today. Now I would like to see all the questions. So whatever questions that you have asked, relevant or irrelevant, and based on that, I will try to answer. Okay, Jatin, I think you have already pasted the same question maybe more than 10 times or 20 times in this chat box. It doesn't make sense actually for me. Don't try to do that. So like I told you already in between a class, in Colab, it is not going to work. So it will not work. So just try to, because you will have to install it. You will have to do installation. So you will have to perform this installation. So just try to do it. I think you will be able to get it. Sandy is saying, feels like you are rushing today. No, Sandy, I don't think so. So it's the same place I'm trying to maintain. Okay. So someone is asking that, okay, so when to use a Plotly or when to use a CBON. So it's completely fine. You can try to use CBON or Plotly, any of this graph anytime. So there is no restriction with respect to uses of Plotly or uses of CBON. So it just depends upon me. If I'm looking for an interactive graph, maybe I can go ahead and use Plotly. If I'm looking for some kind of a static graph, I can try to use a CBON. That is completely fine. So why people are asking question of TensorFlow over here? I'm not able to understand it. Ask this question in your like deep learning class, not here. Folium, so don't try to remove, just don't try to install a Folium package, just remove it. I think that will be better. So you can try to remove the Folium package. Is data gen is used to generate data? Yes, it has been used to generate data. That is true. Cufflinks has been used for the configuration. So if I have to set some kind of a configuration thing, some kind of a background or something in your Plotly, so in that case, you can use our cufflinks. That's the only use of cufflinks. Arun is asking, do we use heat map anywhere in practical data sets? So we use everywhere, sir. So just you will be able to find out a number of use cases. Okay, so now I think I can take some questions, like a live question. That will be much better. Yeah, go ahead with the question and try to ask some valid question. Don't try to ask a stupid question. I'm not expecting that. Yeah, go ahead.
Hello.
Yeah. Hi,
Yeah.
Sudhanshu. I have one question.
One by
That
one. One by one. Yeah.
can I ask question?
Yeah, go ahead, please.
Actually, I want to know that I can I use Plotly in control charts, like, or using Plotly I can create control charts or statistical charts?
Yes, yeah, you can for sure. Plotly is like a control chart, statistical chart, or any kind of a visualization for any purposes. Yes, you can use it. There is no restriction with that.
Because in control chart there is a limit change option is there, like upper limit, lower limit. If like consecutive 8 points or something, we can change the limits.
Yes, yeah, those controls are available. On axis level, those controls are already there. Even into a matplotlib, even into a cmon, so those options are available. Basically, you can control.
Okay.
Yeah.
Hello,
Thank you.
sir. In the heat map and the scatter plot which you have given, like there is a C option there. So what is the difference between these two charts, sir?
No,
Because
see,
the
the same thing I would say. So just based on the color, so color variation, it is going to show you the values. Means, so suppose if I have a x coordinate, if I have a x coordinate, if I have a y coordinate, if I have a z coordinate. So now x is x, y is y, z is, let's suppose, color, right? So based on the value, so for this z coordinate, okay, great. Now you will not be able to talk. So here what will happen is, so here in this particular case, okay, so here what you will be able to find out is, suppose if I have an x-axis, if I have a y-axis, if I have a z-axis, and let's suppose I'm considering z is equal to c. Now, so z value is maybe in between 0 to 10. So we'll try to create a basically color chart. So starting from 0 till 10. So based on x and y values, it will try to give that dot. Suppose x and y is representing one dot. So the color of dot depends upon the value. Suppose if it is 10, so whatever like color I able to see over here in this color map, so it is going to give that particular color. This is what how it behaves with scatter plot with C. Again, heat map does the same thing, I would say. So it try to take another axis as z axis, and based on that, so it is trying to give you a colors. That's the only thing you will be able to find out. So in case of a heat map, we have taken basically like a x1, x2, and so on, y1, y2, and so on, and we had some data. Over here. So if I'm trying to represent x1, y1, means some coordinate, if I'm trying to represent, so it will try to create a entire color, I would say, a scale, and it will try to represent that particular color scale with a different colors, which will be which depends upon the value of this data which is available inside this entire matrices that you have, and it will try to map x coordinate and y coordinate accordingly. So there is a similarity you will be able to find out. So even over here, so it is trying to decide a coordinates based on the colors, and even over here, so it is trying to show you a boxes based on the colors, based on the value. So basically it is trying to pick a colors, so from here, from the color chart or color bar. That's it.
Hi, Sudhanshu.
Sudhanshu
Mithun,
Rajveer. So my question is that we use box plot to identify the outliers. Is there any other use case of this box plot?
Not as such. So yes, if you wanted to know that whether my data set is dispersed or not equally, so generally you will be able to find out that sometime your quartile 2 will be here, or quartile 2 will be in between, or quartile 2 will be here, right? So you
Right.
can decide that, okay, fine. So most of the data set is concentrated in this area. Sometime you'll find this line is equal to this one length, or maybe sometime this much, right? Sometime
Okay.
this much or sometime this much. So you will be able to see a dispersion or distribution of the data set as well, that in between what to what range my data set is more distributed basically, or more
Okay.
concentrated. So even for this kind of insights, you can try to use a box plot. Even for getting outliers, you can try to use a box plot. Even to find out a mean median mode, you will be able to use a box plot. So those things are possible.
Okay.
Sudhanshu,
And heat map, I mean, it is basically used for correlation. Is there any other use case also for that?
Correlations, or I can say like a intensity, to find out the intensity of the data set across the data. So maybe intensity means, so if it is trying to give you a color which is available in a high of up, or maybe which is available in extreme of this entire color bar,
Correct,
right?
correct,
So in
correct.
that case, I can say that, okay, fine. So I have like some data set which is available in that particular place. That's it.
Okay.
okay, hi Sudhanshu, Mithun here. I wanted to know, like, in Plotly, what is the interpretation of the 3D graph? Uh,
Okay, just wait. Okay, am I audible?
yes,
Okay, so so in Plotly, what was the question? In Plotly,
I wanted to ask, like, what is the interpretation of the 3D graph that you had
3D
shown at the beginning of
always gives you a better visualization.
content?
it will always give you a better visualization. So again here, so you can say that, okay, fine. So whatever data set that we have, X or Y or like a Z axis that I have taken, right? So my data set is not that smooth. So my data set is not varying altogether, right? Or you sometimes you will be able to get some kind of a sinusoidal curve. So the code which I have given in yours like a slide, so you will be able to get some kind of a sinusoidal curve, basically some kind of a sinusoidal curve if you will try to execute it. The code is already mentioned inside your slide. So you will be able to find out that, okay, fine. So how my data set is moving, how my data set is behaving, and whether my data set is smooth or not, it's going to create a smooth curve or not, or some kind of a shape or not. So you will be able to get a tendency of the data set with the help of 3D. This is and better visualization. For the better visualization, we always look for the 3D graph.
But then, what can you conclude from this particular data? Like, I'm a
Conclusion,
little confused. I mean,
no,
how it
conclusion
can be used.
conclusion wise, here I can say that, okay, fine. So my data set X and Y and Z, so whatever data set which I have taken, so every row is trying to give me basically a different kind of a space over here. The space over here means, so my data set is not in sync, or I can say that my data set is not moving smoothly, or my data set is not normalized. Every data set is not normalized. This is what I can try to conclude. Or data set, my data set is not representing some kind of a shapes as well. So this is also which I will be able to conclude.
Okay, great.
So
Very
for
interesting.
25
Thanks.
percentile, can we say that 25% of the data is below from that point? Can we say that?
Point. Which point?
If we are saying 25 percentile, so can we say that 25% of the data of that distribution is below that point?
25% of the data. Yes, you can make that one because it's I'm talking about indexes, right? 25th indexes, which I'm talking about, 25th percentile indexes I'm talking about. So yes, in that case, you can try to conclude it for sure.
So,
Hello.
Yeah, go ahead.
Hello. Namaste, sir.
Go ahead with your
Could
question.
you please repeat the column wrap and height, sir?
Sorry?
Column wrap.
Column graph?
Column wrap.
Column wrap is nothing but, so you must have seen that it was trying to show me basically like a six graph in a single row, right? So it was not visible properly to me. So what I have done is, so I have like done this column wrap operation. So so in a single row, just try to show me two columns. This is what I have done, right? So that your graph will be a bit bigger, and then you will be able to visualize it in a clearly possible way.
We can give column wrap for 3 also, sir.
You can give 5 as well.
Okay. Thank you.
Yeah, next question, please.
Hello, Sitanshu.
Yeah, go ahead.
Yeah, actually, can I share my screen? Actually, I have an error. I want to.
What is your question?
I have an visualization error. I am unable to execute this.
Try to ping support team, ma'am.
I have asked them actually, but they could not say anything.
What visualization you are trying to do? What you are not able to do?
This visualization libraries, whatever are there, like Matplotlib, Seaborn, executing on one data set, they got to working on them actually.
No, I will try to upload the same course. So I will try to upload the same thing, whatever I have discussed right today. So by today night, so these things will be available inside your dashboard so that you will be able to execute it. So whatever I have discussed, you will be able to execute it inside your system in a single like a run itself in a single go, and yeah, you will be able to visualize it. That is one thing. Second thing is the data or the like a slide which I have uploaded as of now. So I have added some extra things as well. So when I was practicing, so I have just created some additional tabs over there. So I'll just try to remove those tabs. I'll just try to upload this one. It will work.
Yeah, hi Siddhansu. Like box plot, we are able to. Am I audible?
Yeah, one by one.
Yeah. So like a box plot, we are able to understand outlier and Q and Q3 quartile. So how to interpret this box and plot?
Box and plot is also same. Generally, like a box and plot is available into a Seaborn. I don't use a box and plot, and interpretation wise, it's exactly same. So even into a box plot, we have a quartile range 1, quartile range 2, and all those things. Even over here, so you will be able to find out exact similar thing interpretation wise. The only thing is like the tail one, right? So tail one will be a bit longer in case of a box and plot. Nothing else that you will be able to find out if we have outliers. So it is going to give you a long tail. That's it. If we have outliers, then in that case, you will be able to get a long tail. Nothing else that you will be able to find out.
Okay, thanks.
Yeah.
Hello, Sudhanshu.
Yeah.
Yeah, how frequently we use these graphical libraries in real-time project, or max of the time do
Every
we
project, every project, I would say.
every so for that thing we need to build end-to-end application, maybe using the REST APIs or something where
Yes,
dynamically.
yeah, we do that. No, it's not like that. So whenever on the very first day, whenever you will get your data set, so just to perform the analysis of the data, for sure you are going to use some of these libraries. And yeah, so I can say that from the very first day of your career, you are going to use it.
Okay.
Hi,
Yeah.
Sudhanshu.
Yeah. Go
Sir,
ahead.
actually, I have a similar question to percentile one. So if I'm talking about 25th percentile of the data, and let us say I'm having 100 data sets.
Hmm.
So you said that 25th percentile will be based on the indexing, right?
Yes.
So 0 to 99 if the indexes are for 100 data set.
Hmm.
So 25th percentile will be 24th indexing or 25th indexing?
Why you're asking this stupid question, Manish? I think it's understood, right?
Sorry, sir.
Yeah, great. Next question, please.
Hi, Sudhanshu.
Yeah.
Yeah, can you please explain about the heat map once again and about the in what scenarios would you use it and how will it
I
be
think I
beneficial?
have given answer to this question. So
Yeah.
suppose this is the color graph, right? So again, color is represented from starting from -10 to 60. Now,
Mhm.
so I can see that value, like a data which is having a higher value is represented by blue color, right? Now, suppose if I look into my graph and if I wanted to know that where we have a higher value data, or suppose if I'm talking about maybe a weather prediction or weather forecasting, right? So now in a x-axis, so let's suppose I have this table. So on a x-axis, I have a latitude, and in a y-axis, I have a longitude, and in that longitude and latitude, so suppose I have a wind speed which has been given, right? So wind
Mhm.
speed is different in a latitude and longitude. So latitude versus longitude, so wind speed is given over here. Now I wanted to check that, okay, fine, so in which and all like a latitude longitude, basically what is the wind speed? Agree? So
Mhm.
in that case, what will happen is, so I can try to plot this graph or plot this data. So let's suppose in a layman way, if I'll try to explain you, so this is how you can try to interpret it. So this is the data set which I had. This is the data set which I had. So let's suppose y is nothing but latitude and x is nothing but longitude, which has been given to you. So latitude 0, latitude, longitude 0, right? So on this latitude, longitude, this is the wind speed. Let's suppose we have. This is the dummy data, right? This is the wind speed that we have. Now let's suppose if I or if I'll ask you a question that, okay, fine. So in what in all latitude or longitude, or where we were having a highest wind speed, right? So you can try to hover your mouse in all the blue data set, blue wherever we have a blue, and you can say that, okay, fine, in latitude longitude 18, 19 we have this as a highest value, means we have a highest wind latitude longitude. You will be able to perform that kind of a statistical operation. In what and
Okay.
all area we have a lower wind speed, so you can say that, okay, fine, so in this area I have a lower wind speed, right? So this is how we try to interpret a heat map, basically. So it always try to give you the intensity of the data across
Okay.
like a coordinate x and y coordinates. So z coordinate will be always representing a intensity. That's it.
Okay. Okay. Is
So
this color
for
automatically selected or is there a way
yeah,
that?
so this sets are automatically selected, so you're not supposed to worry about that.
Okay.
Just
Okay.
you're
Got it.
supposed to pass uh, like uh, I would say a kind, and then in that way, so it will be able to give you the entire heat map, as simple as that.
Okay.
Yeah.
Okay. Yeah. Oh, got it. Yes. Yes. Better.
Okay,
Yeah.
fine, guys. So
Okay.
I think I
Thank you.
have taken almost all the questions from every one of you, and I've clarified it. So just try to practice all of those graph, whatever we have discussed. Graph is important. Again, in your machine learning, in your EDA section, these things is going to come all together, and you will have to perform a different kind of operation, statistical operation, different kind of interpretation operation. You will have to perform. So yes, we are going to do it, but at that point of time, I will be using a graph directly. I'll not teach you again what graph is doing what, for sure, because I will be assuming that you remember each and every graph that we have discussed inside the class, and it's nothing. It's just like a passing x value and y value. That's it according to the graph. So graph is not at all a big deal. I have discussed 3 libraries so far, so forth inside your class, which we use widely across our industry, and based on these 3 libraries without with some addition or subtraction, so we will be doing our EDA operations. And next, We will talk about a we'll talk about a MongoDB, and we'll talk about a Flask. And yeah, so last week I was trying to manage all the missed classes for our deep learning batches. This week, so we are going to give you a schedule. So I think we have missed 2 to 3 classes for ML28. This week, we are going to manage each and every classes that we have canceled for ML batches. So last week I was trying to manage my DL batches. This week for ML batches. Tomorrow the agenda will be like MongoDB and a Flask API. So Virat is going to take your class tomorrow, and he is going to teach you how to install a MongoDB. It's a basic thing, so just a configuration thing. Just install it and then call it through a Python and then Flask. And then in a consecutive class, we are going to talk about a project. So probably in this extra classes, we are going to close your project, and then from next week onwards, next Saturday, Sunday onwards, I have a plan to start your statistics, basically. So I'll try to start your study. That's a whole agenda. That's a whole plan for this entire week that we have. So you will be able to receive a mail 24 hours before your classes. So probably your extra classes is going to happen on Monday, Wednesday, and Friday. So you will get a mail from our side. You can try to join it. Those who will not be able to join those classes, so they can look into the recordings. We'll try to upload the recordings as soon as possible after the class. With that, guys, thank you so much, and have a great day ahead. Have a nice weekend.